This is our Arduino code for our project. First, we have to include the DHT library, and then we define DHT pin 2 and DHT 11, since we are using that in our Proteus project. As you can see, the Arduino is connected to DH11 and it is connected to DH2. Then we start coding our program. We got to begin the 9600 to use the terminal and serial.print.n dht.final, which will be the first to print in the terminal, virtual terminal. Then we start the DHT sensor to work using this line. We use three variables, HTF, one for humidity, one for temperature, and one to see if it is in Fahrenheit or not. Then we use an if statement to see if the circuit is able to read the temperature and humidity correctly. If it can't, then it will return an error statement like fail to read from the DHT sensor. If it doesn't do an error, then it will just print the temperature and then the humidity. After that, you just have to compile the code and you will get a hex file. This is a binary file that you need to paste it on the Arduino.
Hello, I'm Sanjida Alam Maliha. For this project, we first need to select Arduino Uno R3 DHT11 physical terminal cum physical interface model. The DHT11 has 3 pins. We will connect the pin 1 VDD with the power source and connect pin 3 with ground. We will use pin 2 for data. We will connect it with Arduino's pin 2. We will put a register between DH11 pin 1 and Arduino's pin 3. And with virtual terminal for connection, we connect its RX pin with Arduino's TX pin. And again, with COM physical interface model, we connect its TX pin with Arduino's TX pin and RX pin with its RX pin. So now we are done with our circuit design. Now we can run it and see our output that we can increase and decrease through virtual terminal.
So I will be discussing about the lab view part. So it has two different sections. First one is the front panel, and another one is the block diagram. In the first diagram, uh, we have the front panel. I have taken humidity, temperature as an input, and for observing these inputs, I have taken the waveform chart, and we have used the table control for different data like our IDs, then humidity, temperature, date, and time. And the second panel, we can see the whole diagram. So on the second panel, we can see that the whole diagram under a while loop which can iterate, and then we have created an array where those data are stored in the fast ports like humidity, temperature, or all are there. So these are all things from my side, and this is the uh, lab view part. So thank you. Done.
Hello everyone, I'm Fardin Hassan Khan from the group quartet, and I'll be giving a complete demonstration of a data logger system. So first I'll start the virtual serial port. I have set a COM3 and COM4 for this project. COM3 has also first been selected in our Proteus in COM3 for the COM pin component, and in our lab view we have selected COM4 for the connection. So if I start running it from here, you can see our table is showing our date, time, and IDs. And from here, if I start my Proteus simulation from here, you can see a project terminal result. 25 is the temperature, 80 is the humidity. You can see 25 is being shown here and 80 is being shown here. You can also see it here in our data table, and you can see it in our temperature thermometer and humidity gauge. Now I can also change it from here. From our Proteus simulation, I am changing in the temperature from 25 to 33. You can see it in our virtual terminal, and you can also see it here from 25 to 33, and it also increased in our thermometer here. You can also decrease it from 30, it's changed to 30, 33 to 30, it's changed from 33 to 30, and also change here. I can also change our also change our humidity from here. I'm changing my humidity from 80 to 70. You can see it here, from 80 to 70. See it here in our waveform also. You can also see it in our gauge here. So that's all.